Hello, we'll go ahead and get started. My name is Meredith Kendrick. I am the product line manager for our data center fiber management systems. And we also have on the phone Keith Sullivan. He is the director of strategic innovation at AFL. So today we're going to go through the DENALI product line. And we will go over this agenda we have here. So we'll do a quick introduction of what is DENALI. We'll go through why DENALI, why now, what kind of value is DENALI bringing. We'll go over a platform overview, go through some ordering guides, and then Keith will dive into an architecture overview, and then we'll have time for questions at the end. There is a question box that you can submit questions to throughout the presentation. You don't have to actually wait till the end to submit your questions. So feel free to do that as we present. All right, with that, I will get started. So what is DENALI? DENALI is our new high-density optical fiber platform. DENALI delivers leading-edge data center performance today while positioning the evolving fiber networks of tomorrow to scale rapidly with increasing complexity of AI and hyperscale cloud environments. The frequent innovation with AI builds is really transforming how data centers approach fiber deployment, and major infrastructure overhauls can be very costly. DENALI was developed to handle faster scaling, reducing time to market, and ensuring the reliability needed in today's environment. So why DENALI? What kind of value propositions does it bring? So DENALI is a future-ready fiber platform. DENALI platform offers a variety of cassette types and connectivity options, including newer VSFF adapters and connectors, and housings use the same tray for all cassette types and sizes. So once a DENALI housing is installed in a rack, these cassettes can be integrated for what is needed today and then upgraded for what is needed tomorrow, requiring minimal infrastructure upgrades. Accelerating AI network deployment. So DENALI was designed for quick one-person installation with front or rear-loading cassettes, removable patch cord managers, pre-terminated cable assemblies with an integrated mounting clip, or what we call an outback clip, that directly mounts into the housing itself. These features really accelerate time to market, reduce labor costs, leading to a stronger return on investment. And then global platform, but local support. So DENALI we're delivering a unified global platform that ensures consistent performance wherever you build. So our regional teams around the world ensure local compliance is met while still providing accessible expertise with these local teams and delivering support tailored to each location. And then simplifying operations from start to scale. So DENALI streamlines the entire deployment process. So since each DENALI housing can accept any size or type of cassette, we have less part numbers, a simplified housing ordering system, which leads to some inventory efficiency and leads to minimizing our build complexities. So a platform overview for DENALI. So we do rely on the kind of the four pillars of our platform. So we have housings, we have cassettes, we have assemblies, and accessories. So first we'll dive into housings. We do offer a standard 1, 2, and 4 RU. So the DENALI platform is a tray-based and cassette-based system. So you slide out the tray, insert your cassette, and then slide the tray back into the housing. The 1 RU can fit up to 3 trays, 2 RU 6 trays, 4 RU 12 trays, so 3 trays per RU. And there's a variety of cassettes you can pair with these housings. So depending on the cassette size, you can fit up to 6 cassettes per tray. So a base 8 cassette size will have 2 LC quad adapters widthwise, and you can fit 6 cassettes in a tray using a base 8 width. For a base 12 width, you have 3 LC quad adapters, so you could fit 4 cassettes into a tray. So really what that tells us is we can fit 72 base 8 cassettes in a 4 RU or 48 base 12 cassettes in a 4 RU, which allows for 576 fibers using LC connectivity And if we're using an MPO 12 patch cassette, we can fit up to 3,456 fibers per 4RU. Using an MPO 24, 6912 fibers per 4RU. So really, we're maximizing our density here. Some of the features for our Denali housing. We offer standard rack compatibility, so we do support a standard 19-inch rack, and then we have an accessory kit for a 23-inch rack configuration. Basically, that's just new brackets to replace the 19-inch brackets. Flexible cassette installation. We can install cassettes from the front or the rear of the housing on the tray. So allows for some flexibility when we're installing our cable assemblies and installing cassettes themselves. Versatile routing, so we can run assemblies to the left or to the right, depending on our connection needs. In the front or the back of the housing, we can run it both ways or run it just one way, depending on what rack you're working with. Front loading trays, so our trays are sliding at the front, and we also have the same tray, as I mentioned, for all cassette sizes and types, so it really simplifies our access and our handling with the trays themselves. Dual hinge doors, both the front and the rear doors hinge at the bottom for some convenient access. Efficient cable management, we have easy access for our streamlined loading and patching in our housing. Rear cable support, this is really talking about our rear cable management area in the back of the housing, where we can directly mount the outback clip that comes on the cable assembly into the housing itself, so you're not mounting that clip or that cable anywhere outside of the housing. Clear identification, we do have port label templates that come with the Denali housing to help facilitate any maintenance, upgrades, troubleshooting, etc. Sliding lockable trays. Our trays slide out and lock in place for simplified patching and maintenance. Removable patch cord managers. These really enhance our flexibility and organization within the housing. So you can actually remove the patch cord managers, install your cassette, test your cassette, maybe troubleshoot if needed, and then install the cable manager so you have more access to your cassettes and to your connectors. And then a scalable design. So cassettes can be installed or swapped to suit any adapting or new fiber networks. Diving into Denali cassettes. So we have 3 different types: fan out, patch, and splice. A few features on the cassette itself. Again, these are front or rear loading cassette for flexible installation. We offer these in a base 8, a base 12, a base 16, and a base 24 configurations in fan out and patching cassettes, and then in splice cassettes in a base 12, 16, and 24 configurations. There we do have a front and rear easy release cassette lever. So the lever actually auto adjusts when you release it from the housing, so you can go ahead and reinstall it if needed. And then we offer shuttered LC adapters and shuttered MPO adapters in these cassettes to eliminate any dust caps, enhance our laser eye safety, and simplify our fault detection. So the Denali MPO fan-out cassettes, a few more details on these. We offer these in base 8, 12, 16, and 24 configurations. So that allows us to put up to 24 fibers using LC connectivity in a base 24 cassette. This allows us to enable speeds from 10 gig to 800 gig. We do design these with our method F polarity. So if you don't know what method F polarity is, we use it as our internal polarity management that allows the same cassette orientation at both ends of the link. So you don't have to do any cassette flipping with maybe a standard, method B polarity. Our polarity F has a different internal wiring than a standard cassette. And then we utilize low loss empty ferrules for premium network performance on these cassettes as well. And we do have these available with SN as well as LC for our front fibers. Denali patch cassettes, similar to the fan-out cassettes, we offer these in base 8, 12, 16, and 24 configurations. So again, allows us to put 24 fibers per cassette using a base 24 cassette and LC adapters. If we're using MPO adapters, we could put up to 12 MPO ports per base 24 cassette. and again, enable speeds from 10 gig to 800 gig. Splice cassettes, so a little different here. We offer these in base 12, 16, and 24 configurations. We do not have this available in a base 8. Just the mechanics of the splice cassette themselves are too small or too big to put in a smaller size cassette. But we do offer this in a larger base 24 size to accommodate those 24 fiber subunits that you often see in our cable assemblies these days. Really seamless integration. These are preloaded and pre-routed with pigtails, and we do offer this in single fiber or coated ribbon fiber splicing. So this is really built for, again, fast one-person installation. You can splice conveniently away from the rack, and we've done some field testing that shows that ribbon pigtails offer 60 to 75% faster field splicing as compared to a stranded pigtail. A little more information on our method of polarity, just as an FYI, we do actually have an application note available for this online if you want to read up on it anymore, just to get your bearings around method F. But some of the features are that the MPO connections all utilize key up to key down adapters. So you'll see this actually in our ordering guides. We do specify key up, key down adapters. Polarity, as I mentioned, is managed inside the cassette. So the wiring is basically flipped. So you don't have to manage it with flipping the cassette itself. Again, it eliminates the need to order various types of cassettes and trunk cables and patch cords at the end of the day. So trunks are key up, and non-penned in the middle of the cassettes. And then if any extender trunks are needed, these are made with one key up and non-penned, and then one key down and penned, which really allows us to offer an end-to-end solution with minimal part numbers. So you're not ordering a different part number per cassette, per patch cord, per trunk cable. A few more details on our DENALI MPO trunk cable assemblies and our patch cords. So our MPO trunk cable assemblies are available in base 8, 12, 16, and 24. We do utilize our low loss premium MPO connectors to ensure, low insertion losses in these high speed network environments. We do offer optional pulling eyes for easier installation, and we typically utilize our reduced diameter microcore cable that utilize 2 millimeter subunits up to 144 fibers. Above that, we're utilizing mostly our rack and tube cable, and we do have additional cable options if that's of interest to any of your customers. And then we also utilize our integrated outback clip. You may see it also called the Rock and Lock clip for our secure housing attachment. Basically, this clip just goes into the back of housing. It attaches to the bridge lances we have in the back of housing, so you don't have to worry about attaching the trunk cable anywhere else. And then our LC patch cords, we do utilize the extended push-pull latch on the LC unit boot for improved accessibility. These are also tool-free field reversible, and we use our small diameter cable here for our patch cords to improve airflow and reduce any cable congestion in the patching area. So some additional information on how to order our housings and our cassettes. So we'll start with housings here. Pretty simple. As I said, we have fewer part numbers for our housings. So for our housings, you just order by brand, RU size, and housing type. So for Denali, that's Denali-1, 2, or 4 RU, depending on what size you need. And then the housing type, we only have one. It's standard. Pretty simplified ordering there. For our fan-out cassettes, we do have additional options, so it's a little more complicated. So we start again with our brand. We have Denali Cassette. We have our cassette type, which is for this one a fan-out cassette. So we have the abbreviation FC. You'll see all of our cassettes start with DC dash, and then they'll have the cassette type designated. Then we move into our rear adapter count. So if we're using a 112 fiber MPO adapter, we will have rear adapter count 1. And then rear adapter type is MUD, MPO key up, key down. And then we move into our front fiber count. So front fiber count and then front adapter type. So if we're using 12 LC UPC connectors and adapters, we'll have 12 ULC. And then fiber type would be single mode for LC UPC adapter. And then polarity, our standard will come as method F. We do have method A available if you are using a different polarity method. And then our Denali patch cassette. Again, we'll start DC-PC for patch cassette. Then we have our front fiber or port count and front adapter type. So for here, if you're using a single fiber adapter, we'll use front fiber count. If we're using a multi-fiber adapter, we'll use front port count. So I'll give you two examples. So for a 12 fiber LC UPC patch cassette, we'll do 12 ULC. If we're using a 6-port MPO cassette, we'll do 6 MUD for MPO key up, key down. And then fiber type for your 12 ULC will be single mode. If you're using an MPO adapter here, your fiber type will be all because our adapters do not designate a fiber type here. All right, splice cassettes. So again, brand DC, cassette type SC for splice cassette. Similar to our patch cassette, we'll have front fiber count and then front adapter type. And then you'll have fiber type. And then on this one, we'll have fiber bundle. So basically, what are your pigtails looking like? Are they stranded or are they coated ribbon? So you'll have the S designation for stranded and then R designation for coated ribbon. All right, and that is all I have for you. So I'll turn it over to Keith Sullivan to go over some of our architecture information.
Thank you, Meredith. Good afternoon, all. I'm not sure if there's anyone here from Europe. I'm sure you can hear from me that I'm not from the US. I'm actually sitting in Dublin at the moment. So thank you all for joining. As Meredith said, there is a little questions box at the top of the screen. So if you have any questions, just type them in there and we'll address questions at the end. So I'm going to run through kind of 3 pretty standard, what I would call vanilla options from how we put together a solution. And these documents are on the website. So we have kind of traditional enterprise data center, kind of the main distribution area to the server solution using Denali. It's a little brochure, PDF. I don't know, it's about 8 pages. You can download it. You can scan the QR code there on the right, or go to the website down on the bottom, and you can download these and lots of other solution guides. We are actually currently working through a AI solution guide, which will cover all of the AI solutions. That'll be out in about a month to 6 weeks, and that'll be on the website also. So it's worthwhile checking back to this website page for all of the different reference architecture documents that we have. Next slide. So I'm going to go through what I would call a vanilla enterprise type of data center. So it's not a cloud data center solution. It's enterprise, and then the third solution I'll look at is a pretty simple AI type of solution. So here, the first one, we're going to go from the main distribution area in a traditional data center, traditional on-prem enterprise type of data center out to a server rack. So the MDA would be in the network rows or the core or the spine or however you want to refer to it. And you can see in the picture here, we're going path A with a red route and path B with a yellow route, whatever you call your diverse paths. But we're going to do a bill of materials run through for running 24 fibers diversely, and then we'll do it for 48 fibers diversely from the MDA out to the server rack. So you can see on the left, we've got a 4RU in the MDA, because the MDA is going to feed out to many, up to like 300 server racks in enterprise data center. It could be anything from 20 up to 300. If it's a cloud data center, it could be up to 5,000. So it's just difference in scale, really. And then we're going to have MPO to LC fan-out cassettes on each end. So if it's MPO to LC, we have a multi-mode, a single mode. We've got a base 8 and we've got a base 12. So it's kind of, if it's multi-mode and LC, it's most likely kind of a 10 gig, and you can then upgrade it to a 100 gig by having MPO connectivity in the switches and in the panels. Next slide. So if we take the 24 fiber solution, plenum cables, it's pretty straightforward. All we have is, let's say we've got the 4RU in the MDA. So this is a 24 fiber solution. So if you remember, we've got 24 fibers going diversely. So that takes 48 fibers altogether. So if it's a base 8, then each trunk, or the full 48 fibers will have 6 cassettes on the MDA end, and they'll have 6 cassettes on the server rack end. So hence at the bottom there's 12 cassettes. And then if you're doing the base 12 with 48 fibers, base 12 gives you 4 cassettes on the MDA end for the 2 trunks and 4 cassettes on the server end, giving the 8 down the bottom. So we just have, you go through there, the part numbers that Meredith went through, very straightforward. It's the same 4RU housing and 1RU housing for both solutions. Obviously, if it's 4 base 12 cassettes on each end, that takes up 1 tray of the housing. So the 1RU at the server rack is only 1/3 populated, and then for 48 fibers, running 24 fibers diversely, that takes 1 tray of the 4RU. So in actual fact, the quantity here should be 1/12 of a 4RU housing for each server rack, because you would get 12 server racks fed from 1 full 4RU. And then just very, very briefly through, I don't want to spend too long on the trunk part numbers. It looks pretty complicated, but once you get used to it, it's pretty straightforward and a kind of an intelligent part number. So the PFEF is a multi-mode MPO Pro. The E is the 8 fibers, and then the F is female. So it's PFEF, PFEF, the 2 MPOs, PL for plenum, 24 for 24 fibers. C denotes the OM4 fiber. XXXM is the length. And then you've got PA, which means the pulling grip and A. MF, method F. RS is the rock and lock outback clip, small. And then 8 is base 8, and then Denali. So all of the trunks, once you get used to them and done it a few times, it becomes fairly intuitive, and you can actually just make them up on the fly once you've done it 10 times. And then the MPO fan out cassette, Meredith went through them. We got basically the base 8 OM4s, then the single mode, and then the base 12 OM4 and single mode. So I think this particular solution, I don't think you can get any more plain, simple solution in any data center than just going a 4RU to 1RU in a server rack. Bog standard, really simple. Next one, Meredith, please. And then this is exactly the same, except it's 48 fibers. So you still have you change the fiber count of the trunk to a 48 fiber instead of a 24. Oh, sorry, there is a typo in there. It's cut and paste. Sorry, all of those trunks still show 24 fibers. They should show 48. My bad, I'm sorry. So they should be 48 fibers, and everything else changes. Everything else remains exactly the same. You've got 2 of them on the base 8. Now you've got 96 fibers. So on a base 8, 96 fibers is 12 MPOs. So you got 12 at the server end, 12 at the MDA end. So your count for your fan out cassettes goes to 24. And then 96 fibers on a base 12. 8 MPOs, so you got 16 cassettes on each end of the MDA and the server. So it's all exactly the same. Trunks should be a 48, they're 24. Apologies for that. I'll get it fixed before we kind of distribute or send anything out. That's a very simple, straightforward, bog standard solution. Next one. So then this is kind of, again, in an enterprise type of environment, going from the main distribution area out to a SAN environment. This is, running, you can either run 96 fibers or 144. I focus on 144s. Out of the MDA to the SAN. This solution just focused this on LCs on both ends, but on the MDA end we had MPO to LC finite cassettes, and on the SAN end we've gone with MPO to LC finite cables that would go from the top of the rack panel down to the SAN equipment and plugging in with LCs. So it's MPO to LC finite cables on the SAN end. And for both base 8 and the base 12, just focused on the 288 LC ports, which would be 576 fibers. Okay, moving on. Next slide. Right, there we go. So yeah, for 288 LC ports, we put the 4 RU housing obviously in the MJ, 1 RU at the SAN. At the 4 RU, we are going to kind of have the MPO finite cassettes, so 288 LC ports. On base 8, you get 4 LC ports per cassette. So then the 288 divided by your 4 gives you your 72 finite cassettes. So there's on each end there'll be 72 MPOs, MPO panels, cassettes, the patch cassettes. So we got the same 4 RU, 1 RU. We got the 144 fiber trunks on both of them. On the left is the base 8, denoted by the connector code, the PFEF. And you can see on the base 12 is PFTF, with the T just standing for 12 fibers. And then it also has obviously the base 12 at the end of the part number. So both on the, if it's a base 8 solution, the 288 LCs, there's 4 LCs per cassette, so that brings me down to 72 count for the MPO to LC finite cassettes. And the base 12, there's 6 LC duplex per cassette, so that gives you your 48 count of MPO to LC finite cassettes. And that's just the amount of cassettes purely at the MDA end. And then for the MPO patch cassettes, there's in the base 8 solution, both of these, so the base 8, if you use a base 8, so the smaller width cassette, you would get a 4, it's either 4 mud in the part number. That means 4 MPOs on the front, key up, key down. So we need 18 times the 4 gives you your 72 MPOs. And then on the base 12, you have the 6 mud, which means 6 MPO key up, key down on the kind of a wider cassette, for which you get 4 of them in a tray. So it's 12 times 6 gives you your 72 as well, MPOs. And then for on the SAN end, you're going to go with an MPO to LC finite cable. It could be 2 meters long, which would be an M2 at the end, and these just the OM or the base 8. So it'll be MPO to 4 LCs, and on the left is MPO to 6 LCs. So an MPO 12 to 6 LC duplex, and that gives you a whole. It's a LC patching at the MBA, and then you're dropping a MPO to LC. People call them hybrid cables, finite cables, whatever you want to call them, QSFP cables, whatever, down straight into the SAN equipment. Okay, next slide. And then this here is, again, a very vanilla type of solution. This is kind of looking at an AI solution. So we go from a GPU server rack to a T0 switch rack, which normally be at the end of the row of a GPU rows, or it could be in the middle of the row. But your T0 switch rack will be your layer 0 or your leaf or whatever you want to call it. And to put this in, it's very simple. This would be running down a row, might have 8 or 10 GPU racks, and then running to a T0 switch. So we're going to have the server rack with a pretty standard solution. You have 4 NVIDIA H100s or H200 GPU servers. Each of the H100s, H200s have 8 MPOs plugging into them. So with 4 of those servers in a rack, it's 32 MPOs. So what we're going to use is we're going to use 2 144 fiber MPO8 trunks going from the GPU top of rack switch or top of rack panel on the right there to a T0 Tor panel, which is on the left, which will be has all of the T0 switches. So the 2 144 fiber trunks, 144 fiber trunk is 18 MPO8s. So that the 2 of them gives us 36, which gives us 32 that we need for the GPU servers and 4 spare MPOs, just in case you need the spares. If one of them doesn't work, you can flip over. Okay, and this is just there's no diversity. The diversity comes in the network mapping for the 8 MPOs per H100. And the H100 has 8 GPUs in it, GPU accelerators. So there's 1 MPO pretty much for each GPU in the H100. And 4 is a lot of H100s because they're about 10.5 kilowatts per H100. So this would be a 40 kilowatt rack, which is a lot for any data center. For air cooled. Obviously with the NVL72, you get more. Okay, next slide. So key thing to note here is the big NA on a base 12. Once you go to, well, pretty much any infrastructure in a large modern data center, either base 8 or base 16 is absolute direction we should be going. But especially if we're doing AI, everything should be base 8. Doing base 12 is just wasting fibers, and every single base 12 would have a dead fiber 5 to 9. So left out base 12 and just focus on base 8. We got the 4 RU housing and the T0 switch rack, because you're going to feed many GPU racks, well, 8 to 10 GPU racks into one T0. So you want to have enough room in there. And if we have 18, sorry, we've got 36, so each tray of a Denali housing can take 24 MPOs, whether you put it into a base 8, so a narrow cassette, or a base 12, a wide cassette. The only difference between base 8 and base 12 on an MPO patch cassette is whether you put 4 MPOs in the front or 6 MPOs in the front. On these, I did 6 MPOs in both. It's just easier to manage and works well. They are base 8 MPOs, but you still plug them into the 6 MPO patch cassette. So with the 36 MPOs from each server rack, that will be 1 tray and a half. So for your 12, you get 8 server racks you can do in one 4 RU housing. And then a 1 RU housing in each of the server racks, each taking kind of 1.5 trays. And then you got your 144 fiber trunks, base 8, pretty straightforward. But here, fundamental difference between this and the previous solutions, here we're running male-to-male trunks. So you want to keep the trunks male running down the row, and then your patch cords going from the front of the patch cassette to either the GPU or to the into the T0 switch rack will be female to female, and both on the same end. If you made the trunk female, then on each end you would need a male to female patch cord, which just makes it ever so slightly more complicated. So you're better off keeping your patch cords female to female, method B, and then the whole system works. And then 12 patch cassettes for obviously between single mode and multi-mode. Patch cassette is exactly the same on both, because the fiber type all at the end, we just as a standard use a black MPO adapter in the MPO patch cassette. So it doesn't matter whether it's single mode, multi-mode, or whatever, the same part number. And then the patch cords on the other end. So the patch cord is 64 because we have 32 active MPOs and 4 spares. We don't need patch cords for the spares. So 32 on each end gives you 64 MPO patch leads. I put them in there as, I was going to change them to 2 meters. In there is X meters, so the MX at the end, and you can do FX if you really wish to have it in feet, but feet or meters, whatever, 2 meters, probably plenty if you're patching from top of rack down to a switch. And that, I think, is it. Thank you very much. So these here, they're 3 what I call extremely vanilla solutions. It's very, very rare we do solutions that simple. If you do have an application or you're trying to design a data center or you want some alternative to existing designs, please just reach out, come and talk to either myself, Meredith, or your local AFL person, your local contact, and we love to sit down and work out problems with you and see how we can put this together in a smart way. So those are 3 very basic solutions. We can work out whatever solution you want, and would love to work with you on it. Thank you very much. Any questions?
Yeah, if you have a question, you can put it in the question box. Happy to answer them now, or if you have a question later, you can, of course, as Keith said, contact your local sales rep that you work with, or one of us as well. So, no questions. Do we do a perfect job?
I was about to say, yeah, Meredith, you did a great job. Answered all the questions. We did do somebody had their hand up there. I'm not sure if we can unmute. I don't have. Maybe I do. Let's see if I can unmute. No, I don't have the ability to unmute. Who's it? Jorge or George Salinas? If you can type your question into the box, that would be sorry for the inconvenience. I'd rather talk and ask my question, but if you type your question into the box, then we'll one of us, i.e. Meredith, will give you an answer. Thank you, Tony. Any other questions? I assume that beautifully refers to Meredith.
All right. Well, if there are no questions, we appreciate your time today, and I want to thank you for joining. So yeah, if you have any more questions after this, please let us know.
Hello, I think George. I apologize if I'm mispronouncing your name. Either George or Jorge is saying hello, so maybe he's asking a question. It's okay. All done. And please, we're all our names at AFL Global. If you want to email a question later or have any other comments, queries, questions, please do reach out. Thank you very much. Give you 20 minutes back. Thank you all.